Yeah, I think when people think of space factories, they're either thinking of like humans up there or like 6 degrees of freedom, like robot arms moving things around a crazy conveyor belt. It's none of the above. It is an extremely, extremely simple system. And that's the whole thesis behind the company, is that it turns out you can produce things in the microgravity environment to space with actually very simple systems and bring them down. And that is much cheaper and faster cadence than going to something that is human rated and the size of the ISS. So our first couple of space factories, they just kind of look like satellites. They've got a flight computer. They've got solar panels that extend. On top of that, there's a little quote-unquote space factory, but the materials that we're producing, it's very simple thermomechanics. Think like a couple heaters, a motor, a little storage system, a camera to observe the process. Again, these aren't robot arms moving around. It's heating some things, manipulating a little bit of pressure, and putting it into a package. And then the thing that looks a little bit funky relative to most satellite missions is there's like a little miniature like Dragon capsule sitting on top of that. It's very small. It's basically like a huggable sized capsule. And that's where when the materials are all done, they basically go into that reentry capsule. The reentry capsule separates from the rest of the vehicle, i.e. like that satellite in the factory. The reentry capsule brings the materials back down to Earth and lands on land. We pick up those materials and sell them to our customers. And then ideally, we just increase the cadence of that. And so in some ways, like space factories, they just look like satellites, and they're about 300 kilograms. If you saw them in the night sky, they would look like any other satellite. There's definitely no humans on board. There's no crazy robots on board. They're very, very simple. Now, as we start to show success with that, we start to show positive unit economics. Yes, we'll make those bigger. They'll start to look like very big satellites, and then they'll look like the size of a school bus. And then one day, yes, potentially, they're the size of the ISS and they're fully automated. One day, they're 10 times the size of the ISS, and maybe there's a section of it that we actually human rate and have some humans up there. But that is like far, far down the line. And so I think part of why both investors and engineers have been so invigorated by our approach is it's a very pragmatic step-by-step approach. Prove the market, prove the technical roadmap. We're not trying to go to some sci-fi vision of like some crazy station in orbit that's got humans in it and like that stuff is 10x more, not even 10x more, 1,000x more expensive, 1,000x more complicated, involves a lot of regulations. We're just doing stuff that just looks like satellite missions. Just the unique part is most satellites just take photos of the Earth. We instead like manipulate some materials while we're in microgravity. And then the particular unique part is like our satellites come back down and they have a ride down. Most satellites obviously just burn up when they enter the atmosphere. Ours intentionally survives when it enters the atmosphere and actually lands in a very precise area so that we can pick up those materials.